Completing the square Part 1. In this video, you'll learn what it means to complete the square and describe how to do it. You'll also learn how to solve quadratic equations by completing the square and finding square roots. To complete the square means to add a constant term to a quadratic expression to form a perfect square trinomial. So if we have an equation x squared plus 6x equals 7, our first step is to start with an equation in the form x squared plus bx equals c. This just means that the constant will be on the right side of the equation, and ours is already like that, so we can go to step 2. Step 2 says to find the value that completes the square, so we'll take half of b and then we'll square it. So in our example, b is 6. So we'll divide 6 by 2, which gives us 3, and then we'll square that, and that gives us 9. Step 3 says to now add this value to both sides of the equation. So we'll add 9 to both sides, and this gives us x squared plus 6x plus 9 equals 16. Now we're going to rewrite the left side as a squared binomial. So if we look at our equation and we remember what a perfect square trinomial looks like, it says that the b term will be twice our factor and the constant term is our factor squared. So that must mean that our factor was 3. So we'll write x plus 3 squared equals 16. Now we're going to solve this using the square root method. So we'll take the square root of both sides, and we get x plus 3 is equal to positive and negative 4. So now we'll set up both of these equations to solve them. So we'll have x plus 3 equals positive 4 and x plus 3 equals negative 4. We'll solve by subtracting 3 from each side. So we'll get x is equal to 1. And then we'll subtract 3 on the other equation, and we get x is equal to negative 7. Now let's try another one with the equation x squared plus 12x equals 13. Our first step is to always make sure the equation has the constant on the right side of the equal sign, which ours does. So we'll go to step 2, which says to find the value that will complete the square. Our b value is 12. So we'll take 12 and divide it by 2, which gives us 6, and then we'll square that. So we get 36 that will complete the square. Now we're going to add this value to both sides. So we'll add 36 to both sides of the equation, and this gives us x squared plus 12x plus 36 equals 49. Now we'll rewrite the left side as a squared binomial. So if we look at this equation, we can see that it's the same as x plus 6 squared since the b term is twice of 6 and the constant is 6 squared. So now we're going to solve with the square root method. We'll take the square root of both sides, and this gives us x plus 6 is equal to positive and negative 7. So we'll set up those two equations. We'll solve by subtracting 6 from both sides, and this gives us x equals 1. We'll subtract 6 on both sides again, and this time we get x is equal to negative 13. So let's look at some examples. What could be added to each expression to make it a perfect square? Let's start by looking at x squared plus 12x. So to complete the square, we always take half of b and then we square it. Our b term in this example is 12. So we'll put 12 over 2, which gives us 6, and 6 squared gives us 36. So we would add this to our equation, and then it would be a perfect square. Now let's look at the next one. So we'll take our formula again, and this time our b value is negative 6. So we'll put this in for b, and dividing this by 2 will give us negative 3. When we square negative 3, would give us 9. But since we already have a 1 there as a constant, we're only going to add 8 so that when we add it to the 1, we'll get the 9 that would make it a perfect square. Now let's look at the next example. We'll start with our formula again, and this time b is 14. So we'll put that in for b, and taking half of 14 gives us 7, and 7 squared gives us 49. So that's what we want our constant to be in this expression. But since we have this negative 10, we actually need to add 59 so that when we subtract the 10 that we have the 49 that we needed. In this example, we're going to add the number that would make the expression a perfect square. Next, we'll write the equivalent expression in factored form. Let's start with x squared minus 4x. So we'll take our formula, and we see that b is negative 4. So we'll put that in for b, and taking half of negative 4 gives us negative 2. Negative 2 squared will give us 4. So we'll add 4 to our current equation, and then we can write this in factored form as x minus 2 squared. Now let's look at the next one. We'll take our formula again, and our b term is 2. So we'll put that in, and dividing 2 by 2 gives us 1. 1 squared is just 1. So we'll add this to our equation, and in factored form we'll get x plus 1 squared. Now let's look at the next one. We take our formula, and our b term is 14. So we'll put that in, and dividing 14 by 2 gives us 7. 7 squared will give us 49. So we'll add that to our equation, and then in factored form we have x plus 7 squared. Now let's look at the last one. We'll take our formula, and our b term is 24. So we'll put that in, and when we divide that by 2, we get 12. And when we square 12, we get 144. So we'll add that to our current equation, and now we know that the factored form would be x plus 12 squared. In this example, we're going to rewrite each expression so that it contains a perfect square. Let's start with our first one. We can see that it already equals a constant, so we can jump to step 2, which is to use this formula to find the number that will complete the square. So we'll replace b with 8, and 8 divided by 2 gives us 4, and 4 squared gives us 16. So we'll add this to both sides of our equation, and we get x squared plus 8x plus 16 equals 18. We'll turn this into a perfect square by putting x plus 4 squared equals 18. Now let's look at the next one. So this one is also already set to a constant on the right side. So we'll jump to step 2 where we find the number that completes our square. b will be replaced with 10, and half of 10 is 5. 5 squared gives us 25. So we'll add this to both sides of our equation, and this gives us x squared plus 10x plus 25 equals 12. Now we'll turn the left side into a perfect square trinomial by putting x plus 5 squared. Now let's look at our third one. This one is also set to a constant, so we'll jump to step 2. b will be replaced with negative 14, and half of negative 14 gives us negative 7. Squaring negative 7 gives us 49. So we'll add this to both sides of our equation, and this gives us x squared minus 14x plus 49 equals 54. We'll rewrite the left side as the perfect square, so we'll put x minus 7 squared. Now let's look at our last one. We can start with step 2 again. So we'll replace b with 2, and 2 divided by 2 gives us 1. 1 squared still gives us 1. So we'll add this to both sides of our equation, and we get x squared plus 2x plus 1 equals 1. Now we'll just set the left side to the perfect square version of x plus 1 squared. In our last example, we're going to solve the equations by completing the square. We'll start with our first example of x squared minus 6x plus 5 equals 12. We currently don't have it set to a constant because we have a constant on both sides. So let's move that 5 over to the right side by subtracting it. This will give us x squared minus 6x equals 7. Now we're going to find the number that completes the square. Since b in our term is negative 6, we'll replace b with negative 6, and dividing that by 2 gives us negative 3. Negative 3 squared will give us 9. So now we'll add that to both sides of our equation, and we'll get x squared minus 6x plus 9 equals 16. We're going to rewrite that as the perfect square of x minus 3 squared. Now we'll move it up so we can solve it. We'll start by taking the square root of each side. So we get x minus 3 is equal to positive and negative 4. So we'll set up our two equations, one equaling 4 and one equaling negative 4. We'll solve by adding 3 to both sides. So we get x is equal to 7. And then we'll solve the other equation, and this time we get x is equal to negative 1. So now let's look at our next one. It's already set equal to a constant, so we can start in step 2 by finding the term that completes the square. Our b value is negative 2, and when we cut that in half, we get negative 1. And when we square that, we still get 1. So we'll add that to both sides of our equation, and this gives us x squared minus 2x plus 1 equals 9. We'll rewrite it as a perfect square of x minus 1 squared equals 9, and now we can start solving. So we'll take the square root of each side, and this gives us x minus 1 is equal to positive and negative 3. So we'll set up both of these equations and solve for x. We'll solve by adding 1 to both sides. So we get x equals 4. When we add 1 to both sides of the other equation, we get x equals negative 2. So now we have the solutions to both of these equations. Let's summarize what we've learned. Turning an expression into a perfect square can be a good way to solve a quadratic equation. We can do this by adding a constant to both sides of the equation, making it a perfect square. We can find the constant to add by taking half of the b coefficient and then squaring it.